right, here we go with part 2 of section 8.4. So just took the section, we're going to split it up over 2 days because there's kind of a lot to gather here. And this is definitely a very new concept to all of us, all of you, as we're going through. So what I've saved for part 2 was the portion of this lesson that deals with finding an angle instead of trying to find a missing side length. So all that we've done so far with our trig ratios in part 1 of this lesson was we were always finding a side length, right? They always gave you an angle and one side, and they said, okay, use that information to find another side. So what you're going to see differently on this one now, though, is instead of finding a missing side, we're now going to find a missing angle. So what you're seeing here, so if you look at my calculator, notice above sine, cosine, and tangent, look what's in blue. There's a little sign with a -1 exponent. And then above cosine, you'll see cosine to the -1 and then tangent to the -1. So those little -1s are called inverses. So this is, in blue, you're seeing the inverse sine, inverse cosine, and inverse tangent. And the inverses are what we use to find missing angles. So one of the big things that you really got to separate out, because a lot of times students get confused on this, is they'll say, hey, how do I know whether I should be using like sine or inverse sine? Right? What's the difference? So here's what you got to remember on this. We use the original function, the ones you see in white. Sine, cosine, and tangent are used to find side lengths. The inverses, the ones that you see in blue, are used to find angles. So that's the difference. So finding sides, finding angles. That's the big difference here. So I'm just going to take you through these 3 problems right here to start, because I want to get right into how we do this. Guys, all this still starts with SOHCAHTOA. Okay, so all this still starts by saying, which trig function do I use? Let's set up the equation and solve it. I would always encourage you to write this out at the top of your paper. Like in homework, tests, everything. I would write that out. Right? That's your key on setting up all these equations here. So on this one, they want us to find angle T. So here's angle T. So what are the 2 things that we're dealing with in regards to angle T? Well, this is the opposite leg. This would be the adjacent leg. Right? I'm not working with the hypotenuse right now. I'm just working with the opposite leg and the adjacent leg. So which trig function deals with opposite and adjacent? And we know that's our tangent function, right? Tangent does opposite leg over the adjacent leg. So let's set this up the same way that we did with yesterday. So I'm going to say the tangent. And here's a very important part of this, guys. Remember, next to a trig function, you always need an angle. So if I'm going to say tangent, I need to say the tangent of something, right? It's got to be the tangent of an angle. And in this case, it's angle T. We don't know what angle T is. Right? I don't know what the degrees are, so I'm just going to say angle T, because we don't know what that is yet. And on the other side of this equation, just like we did in the previous lesson, I want to set up the tangent ratio. So from angle T, I have opposite leg, 14 square root 3. Over the adjacent leg, which is 34. All right, so if I was solving this equation, how do I get T by itself? Because really these guys are kind of inseparable, right? It's not like I can just divide the word tangent over, right? Tangent has to be attached to something. So what we're doing to this equation is we are inverting the equation, right? I am finding the inverse of angle T. So the way I can rewrite this is the inverse tangent of my trig ratio, 14 root 3 over 34, is equal to angle T. So this is how you get an angle by itself within a trig equation, is you have to take the inverse function in order to move your angle over to the other side. Okay, and so once you get the letter by itself, as always, this is what now I can put into my calculator. So go over to here with me. So I'm going to type in the inverse tangent of my tangent ratio. So I'm going to do 14 root 3. And I'm going to divide that by 34. So guys, notice I put these extra parentheses in here. That's to tell my calculator that all of this is on top and that this is the only guy on bottom. So sometimes you got to be careful with the way calculators handle those types of things. So by using parentheses, it's just a safer approach to make sure that our calculator is seeing what's on top and what's on bottom. So anyway, here's the tangent, inverse tangent of my ratio, and there's my angle, about 35.5 degrees. So that's angle T. So that's this guy. Just to give you a quick heads up, one of the things we're going to be doing to finish this off is, what if I ask you to find everything that's missing? Like, I already know 2 of the angles. What if I said, what's my missing angle? How do I find angle R? Well, what do we know about these guys? Remember, these always add to 180. And something we've talked about earlier this chapter, if this is 90, what do we know about these 2 smaller angles? They also add to 90. So all you ever have to do on this to find the third angle is subtract this guy from 90, and that would tell you what angle R is. What if I said find the missing side length? Well, what did we do at the very beginning of this chapter? If I know this guy and I know this guy, I can use Pythagorean theorem to find the third side. So I could do a squared plus b squared equals c squared to find the third side. At this point, you actually have options. I mean, I could use a sine function or a cosine function to find it, like we did in the last lesson. I could use Pythagorean theorem like we did at the start of the chapter. You have like all these tools now that we can use for finding these missing pieces, and that's what we're going to be doing down here. So let me go on to the next one. Okay, so again, I'm looking for angle T on this one. So everything we're going to do is from this angle. So see if you can figure out which trig function we should be looking at here. So from this angle, I am looking at the opposite leg and the hypotenuse. So 7 and 18. So which one deals with opposite and hypotenuse? So we know that's our sine function. So we're going to say the sine of angle T equals opposite over hypotenuse. And again, the way that we find our missing angles is by taking the inverse function of our equation. So we're going to do the inverse sine of 7 over 18. In order to get angle T by itself. So again, just go back into that calculator. We're going to type in the inverse sine of 7 over 18. And there's our angle, about 22.9 degrees. All right. And then one last one. Again, I would definitely encourage you guys to try this one on your own. See if you can pause the video and see if you can set this one up and solve it. That is an 87, and that is 34. Sorry if it's a little unclear on the video. I'm still looking for angle T. Let me just mention this while I'm thinking about it. Guys, notice that we never do this from here. We never do it from the 90 degrees, ever. Right? The sine function, cosine function, tangent functions, those ratios must come from an acute angle. They never come from a right angle or an obtuse angle, because obviously you can't have an obtuse angle within a right triangle. So they must come from an acute angle. So I could only use this on R and T. We wouldn't need it for S anyway, right? I already know it's 90. So anyway, so if I wanted to know angle T, from here I'm looking at the adjacent leg and the hypotenuse. So my cosine function is the one that does adjacent leg and hypotenuse. So let's say the cosine of angle T equals the adjacent leg over the hypotenuse. So there's our setup. Since I'm looking for an angle, I want to use an inverse cosine order to find angle T. So if we type this one in, inverse cosine of 34 over 87, we have our angle, which would appropriately round to 67 degrees. So there we go. So this is how we find our missing angles. So keep in mind, guys, we're going to put to use all the tools that we've learned this chapter. So anytime I am looking for a missing angle, I know which tool I can use. If I'm missing a side length, I can use things like sine, cosine, and tangent, or I can use Pythagorean theorem. If I know two of the angles, how would you find your third one? Right, as we said on this one, I would just subtract this from 90 in order to get my third angle. So you have all these tools now for finding missing parts. So the final stage of all this is to now just find all the missing parts. So whenever they say solve the triangle, what they're telling you to do is to find anything that's missing. Any missing angle or any missing side, using any of those tools. So again, consider Pythagorean theorem, consider SOHCAHTOA. We can consider using an inverse function if it's an angle that I'm looking for. If I recognize that it's a 30-60-90 or a 45-45-90, I can use those tools. So it's just now about applying any of those tools that would help you. So as I look at this one thing that stands out to me right away is I know two of the sides. So this is what we did at the very beginning of this chapter. If I know two of the sides, I can use Pythagorean theorem to find the third one. So here's my two legs. I'm just going to put an x here just so I can write this equation. So I'm going to do a squared plus b squared equals c squared. All right, so I'm going to use that to find my missing side length. So 32 squared is 1024. What is 101 squared? 10201, so 10,201. So we're just trying to get x by itself. Let's subtract that 1024. So 9177. And then final stage of this, as we've already seen, is to then square root in order to solve for x. So we're going to do the square root of 9177. And it comes out to be about 95.8. All right, so no longer call that x. Let's call it 95.8. So we now know all three sides. Let's make sure we can come up with all three angles. And of course, we already know this one is 90. I just have to come up with the other two. So if I'm looking for a missing angle, then this is where our inverse functions come into play. So we can pick either one to start with, r or t. It really doesn't matter. I'm just going to pick angle r. All right, so I want to find angle r. So from here, which trig function should we use? Now, I want to encourage you when you're doing problems like this, because you have a lot of options now, because you have a lot of information. So there's many different ways I can do this. What I would encourage you to do is to always use the information that they gave you, not the information that you found. There's a couple problems with that. One is if you got this one wrong and you try to use it to find something else, now that one's going to be wrong too. The other issue is this is not an exact value. We rounded this, right? It's not exactly 95.8. So if this is not an exact value, if I use it to find something else, now that one's going to be a little off from what it really is, right? And so when you're doing these problems, I'd always encourage you to stick with the numbers that they gave you. So if I want to find angle r, I'm going to work with the opposite leg and the hypotenuse, which I now know is my sine function. So I know the sine of angle r is opposite over hypotenuse So 32 over 101. So there's our setup. Because I am finding an angle, I know I need an inverse function. In order to find angle R. So we can go in here. I'm going to do the inverse sine of 32 over 101. Comes out to be about 18.5. degrees. So I know this is 90. I know this is 18.5 degrees. What's our missing angle? You got two options. I could do another inverse function if I want, right? So for angle T, I could do like inverse cosine of adjacent over hypotenuse. That's an option. Nothing wrong with that. So inverse cosine of adjacent over hypotenuse. There's my missing angle, 71.5. What's another way you could do it though? Now that I know this is 18.5, remember what we said, I could just subtract that 18.5 from 90 in order to get my answer. So it's still going to be 71.5 no matter which method I use. All right, it's just two different approaches. All right, so when you're doing ones today where it says solve the triangle, couple things. Definitely show your work. That's important. The other thing is, remember, you can use any of your tools now, right? You can use any of the lessons that we've done all chapter long in order to find the missing parts. So it's just a matter of, whichever method would make the most sense for that situation. So that is it for part 2.